In this tutorial, we will have brief scrutiny of the mesh convergence study. There would be three primary questions that need to be answered. What does mesh independence study really means? And also, why do we need to have a mesh study before starting our simulation process? After realizing the necessity of having mesh study, we will come up with the answer to the how to carry out mesh study question. As a CFD engineer, convergence is something you always hear about, but we must remember that the way we generally define convergence by looking at residual values is only a small part of ensuring that we have a valid solution. For any simulation, we need to ensure that solution satisfies two conditions. The first one is residual error values should reduce to an acceptable value, typically 10 to minus 4 or 10 to minus 5. As you know, at the end of each solver iteration, the residual sum for each of the conserved variables is computed and stored. This residual will go to zero as the solution converges. The second condition is monitor point for our values of interest must reach a steady solution, and imbalances should be less than 1%. So what do you mean by values of interest? Our values of interest are essentially the main outputs from our simulation. So pressure drop, forces, mass flow, etc. We need to make sure that these have converged to a steady value. Otherwise, if we let the simulation run for additional iterations, then you would have a different result. Ensuring that these values have reached a steady solution means that you're basing your decision on a single repeatable value. For instance, our value of interest for the flow inside a pipe with heated walls is the temperature at the outflow pipe. Or in a wind turbine case, moment coefficient is our value of interest, which usually reaches a steady solution after 4 or 5 rounds. So what now? What is relation between mesh study and convergence? The approach outlined till now results in a single solution for the given mesh that we have used. Although we could get to a converged solution based on residual errors and monitor points and imbalances, we need to make sure that the solution is also independent of the mesh resolution. This process should be carried out once for each type of problem, because finer mesh means higher computational cost, so we must try to keep a balance between mesh resolution and accurate results. Notice that using more elements in the mesh grid doesn't always result in more accurate results. The good thing is next time a similar problem arises, you can apply the same mesh sizing. In this way, you will have more confidence in your results. The way we carried out a mesh independence study is divided into three steps. Step 1. Run the initial simulation on your initial mesh and ensure convergence of residual error to 10 to minus 4. Monitor points are steady and imbalances below 1%. If not, refine the mesh and repeat. Step 2. Once you have met the convergence criteria above for your first simulation, refine the mesh globally so that you have final cells throughout the domain. Generally, we would aim for around 2 times the initial mesh size. At this point, you need to compare the monitor point values from step 2 against the values from step 1. If they are the same within your own allowable tolerance, then the mesh at step 1 was accurate enough to capture the result. But what if the value of the step 2 is not within acceptable values of step 1 result? This means your solution is changing because of your mesh resolution, and hence the solution is not yet independent of the mesh. In this case, you will need to move to step 3 and refine the mesh more and repeat the process until you have a solution that is independent of the mesh. As an example, assume that we want to simulate the flow in a two-dimensional channel. Our first mesh grid contains 50 elements in each direction. After that, multiply by 2, we've got 100 elements in second try, and just keep going until the temperature reaches a constant value. As you can see in this plot, 200 elements gives us the most efficient results, so our mesh independence study results in 200 elements in each direction. We hope that you find this tutorial useful. To benefit from MR-CFD services including simulation, consultation and training, contact our experts via info@mr-cfd.com and also www.mr-cfd.com.